On November the 14th, 2023, something happened to Voyager 1 that NASA's engineers had genuinely never encountered before, not in nearly 50 years of continuous operation, and not even during the countless smaller anomalies the aging spacecraft had already thrown their way over the decades. The spacecraft, still faithfully transmitting its steady radio carrier signal across more than 15 billion miles of empty space, suddenly stopped making sense. The data pouring back to Earth wasn't science, wasn't engineering telemetry, wasn't anything anyone at NASA's Jet Propulsion Laboratory could actually read. Despite decades of experience interpreting exactly this kind of transmission, it was gibberish, a single repeating pattern of code over and over, carrying no usable information whatsoever. Voyager was alive. It was listening. It simply couldn't say anything intelligible anymore, and nobody knew why, leaving the mission team facing the very real possibility that decades of continuous operation might be about to come to an abrupt, unresolved end. Like and subscribe if you want to keep following this story, because how NASA actually solved this mystery from billions of miles away is one of the most remarkable engineering rescues in the history of space exploration, carried out by a team working with tools and documentation from an era before most of them were even born. To understand why this glitch was so alarming, you first have to understand exactly what Voyager 1 actually is at this point in its mission. Launched in September of 1977, the spacecraft has been operating continuously for nearly 50 years, traveling farther from Earth than any human-made object in history, having already completed its original flyby missions of Jupiter and Saturn decades, before embarking on what became an entirely unplanned and vastly longer second act. It carries 3 onboard computers, all designed using technology from the 1970s, decades before the personal computer even existed. One of those 3 computers, called the Flight Data Subsystem, or FDS, handles a critical job, collecting readings from the spacecraft's science instruments and its own internal health sensors, then packaging all of that information into a single, organized stream of data that another onboard system can transmit back to Earth. When that packaging process broke down in November of 2023, Voyager kept sending its steady carrier wave, proving the spacecraft itself was still functioning and still receiving commands, but the actual content of every transmission had become meaningless. If you're just discovering this channel, make sure you like and subscribe, because what NASA discovered when they finally diagnosed the problem is exactly the kind of detail that makes this story so remarkable, revealing just how creatively a team can work around hardware that can never physically be touched again. For months, engineers worked the problem with almost nothing to go on, since the very system that would normally help diagnose issues was the one that had broken, leaving the team essentially trying to fix a translator by only being able to speak through the broken translator itself. In March of 2024, the team finally sent a specialized diagnostic command, nicknamed a poke, specifically designed to prompt the FDS computer into sending back a complete readout of its memory, both its software code and its stored data, even though it couldn't properly process anything on its own. That poke worked. When the readout finally arrived back on Earth, after the better part of a day traveling at the speed of light, engineers discovered the source of the problem. A single, malfunctioning memory chip responsible for storing a portion of the FDS computer's code had corrupted roughly 3% of the system's entire memory. NASA suspected the chip had either been struck by an energetic particle somewhere out in deep space, or had simply worn out after operating continuously for nearly 5 decades, though engineers admitted they couldn't be completely certain which explanation was correct. Here on Earth, fixing a problem like this would be almost trivial. You'd simply replace the faulty chip, a job that might take a technician a few minutes with the right tools. 15 billion miles away, replacing anything is completely impossible. Whatever code had been stored on that damaged chip needed to go somewhere else within the computer's memory, and it needed to keep functioning exactly as before, all without a single human hand ever physically touching the hardware. The team's solution was as elegant as it was unprecedented, breaking the affected code into smaller sections, small enough to fit into scattered pockets of free memory elsewhere in the system, then carefully rewriting the internal cross-references so those separated pieces would still function together as one coherent program, exactly as the original code had, a task roughly comparable to disassembling a working machine into pieces small enough to hide in gaps around a room, then rewiring everything so it still runs perfectly once reassembled in that scattered configuration. Engineers began with a portion of code responsible for packaging the spacecraft's basic engineering data, reasoning that restoring that information first was the necessary prerequisite for understanding the rest of the spacecraft's overall health and condition. A logical starting point, given that engineers still had almost no direct insight into how the rest of the spacecraft was actually holding up. They sent that first relocated block of code across the void on April the 18th, 2024. The signal took roughly 22.5 hours to reach Voyager 1, traveling at the absolute speed limit of the universe, and it would take almost as long again for any response to make its way back. On April the 20th, confirmation finally arrived. The fix had worked. For the first time in 5 months, Voyager 1 was sending back readable, meaningful engineering data once again, restored not through any physical repair, but through nearly 50-year-old software, carefully rewritten and redistributed from a control room on Earth to a computer drifting through interstellar space. Over the following weeks, engineers repeated the same painstaking process for the remaining affected sections of code, gradually restoring full science data from Voyager's 4 still operating instruments, methodically working through each corrupted region, one careful transmission at a time. Suzanne Dodd, Voyager's project manager at NASA's Jet Propulsion Laboratory, had been remarkably candid about the odds during the darkest months of the investigation, admitting to reporters that getting the spacecraft back would be nothing short of a miracle, while insisting the team hadn't given up. That miracle, built entirely out of careful engineering, patience, and nearly 5-decade-old code, ultimately arrived, restoring a spacecraft that many outside the mission had quietly begun to write off as beyond saving. But the 2023 gibberish incident wasn't actually the first time Voyager 1 had thrown NASA a genuine surprise, and it wouldn't be the last. Back in May of 2022, the spacecraft had already experienced a smaller, earlier version of a similar problem, suddenly sending nonsensical attitude articulation and control data, information related to how the spacecraft orients itself in space, a warning sign in hindsight that the underlying memory hardware may have already been beginning to fail years before the full breakdown occurred. Engineers resolved that earlier issue by rerouting the relevant telemetry data through one of Voyager's other onboard computers entirely, a temporary workaround rather than a true fix, one that may have set the stage for the far more serious breakdown that followed roughly 18 months later. Then, in the summer of 2025, Voyager 1 surprised its ground team once again, this time in a way NASA hadn't seen since the earliest days of the mission back in the 1980s. Engineers discovered that the spacecraft had autonomously switched over to its backup S-band transmitter, a secondary radio system that had originally been intended only for early mission use, and had remained completely powered off since 1981, sitting dormant and untested for over 4 decades, before suddenly, unexpectedly, coming back online on its own. Nobody had commanded that switch. Voyager's own onboard fault protection systems had apparently made the decision independently in response to conditions the ground team hadn't anticipated. The backup transmitter's signal was noticeably weaker than the primary system Voyager normally relied on, complicating an already difficult diagnostic process that, once again, required every single command and every single response to travel the better part of a day each way across the growing distance between Earth and the spacecraft. More recently, in early 2026, Voyager 1 delivered yet another unexpected jolt. During a routine, previously planned roll maneuver on February the 27th, a standard procedure used periodically to calibrate the spacecraft's magnetometer instrument, engineers noticed something they hadn't anticipated. Voyager 1's power levels dropped unexpectedly, catching a team that had grown accustomed to the spacecraft's slow, predictable decline entirely off guard. That drop mattered enormously, because any further decline risked triggering the spacecraft's undervoltage fault protection system, a safety mechanism that would automatically begin shutting down onboard components to protect the aging power supply, potentially in ways that could be difficult or even impossible to safely reverse from such an extraordinary distance. Faced with that risk, mission engineers made a difficult, deliberate decision. On April the 17th, 2026, the team permanently powered down Voyager 1's low-energy charged particles instrument, known as LECP, an instrument that had been operating almost continuously since the spacecraft's original 1977 launch, nearly 49 consecutive years of uninterrupted service, longer than the vast majority of scientific instruments ever built, have managed to remain functional at all. LECP had played a genuinely critical role in Voyager's ongoing interstellar mission, measuring low-energy charged particles, including ions, electrons, and cosmic rays, originating from both our own solar system and the broader galaxy beyond it. Data that had helped researchers detect pressure fronts and shifting regions of particle density in the strange, poorly understood space beyond our sun's protective bubble. Information no other spacecraft anywhere in the solar system was positioned to gather. Kareem Badruddin, Voyager's mission manager at JPL, acknowledged the difficulty of the decision plainly, noting that shutting down a working science instrument is never anybody's preferred outcome, but calling it simply the best option available given the spacecraft's rapidly diminishing power supply. Remarkably, NASA hasn't entirely given up hope of eventually reversing that shutdown. Engineers have developed an ambitious new power management strategy, nicknamed internally the Big Bang Fix, designed to more efficiently manage the small remaining trickle of electricity. Voyager's aging radioisotope power source can still generate, a name that captures both the significance of the attempt and the small, dark humor engineers often bring to nursing along hardware this old. The plan calls for testing this new approach on Voyager 2 first, since that spacecraft currently has slightly more power margin to work with, making it the comparatively safer test subject for a genuinely experimental fix. If those tests, planned for May and June of 2026, prove successful, engineers intend to attempt the exact same procedure on Voyager 1 sometime after July. And if that attempt also succeeds, there remains a real possibility that the recently shut down LECP instrument could eventually be switched back on. What makes all of these separate incidents so remarkable, taken together, is what they reveal about just how thin the margin has become for keeping a nearly 50-year-old spacecraft functioning at all. Both Voyager probes rely on radioisotope thermoelectric generators, devices that convert the steady heat released by decaying plutonium directly into electricity, a technology chosen specifically because it requires no moving parts and no sunlight, essential for a spacecraft destined to travel far beyond any meaningful solar illumination. That power source has been fading gradually and predictably since launch, losing roughly 4 watts of available power every single year, a slow, inevitable countdown that no amount of clever engineering can ultimately reverse, only delay. Every fix NASA has managed to engineer since 2023, the relocated flight computer code, the mysterious autonomous transmitter switch, the careful shutdown of a decades-old instrument to prevent a much larger failure, represents the exact same underlying story. A small, dedicated team of engineers working from a control room on Earth, reaching across a gap now measured in nearly a full day of radio travel time to keep a piece of 1970s technology, functioning just a little bit longer than anyone reasonably expected it to. As Voyager 1 approaches its historic one light day milestone in November of 2026, expected to occur on November the 15th, when the spacecraft reaches a distance of roughly 16.1 billion miles from Earth. The fixes NASA has engineered since that first gibberish transmission back in 2023 stand as proof of something genuinely remarkable. That even hardware, nearly 50 years old, isolated farther from home than any human creation has ever traveled, can still be coaxed back to life by patient, careful engineers willing to rewrite the rules from a full day's radio signal away, working in shifts, generation after generation, on a spacecraft. Most of them weren't even alive to see launch. Nobody expects these fixes to last forever. Voyager's power supply continues, fading regardless of how cleverly its remaining watts are managed, and at some point, likely within the next few years, no amount of ingenuity will be enough to keep it transmitting, a reality every member of the mission team openly acknowledges, even as they continue searching for one more clever workaround. But for now, against every reasonable expectation set when it first launched in 1977, Voyager 1 keeps talking, keeps surprising the people who built it, and keeps proving that the story of humanity's most distant machine is far from finished. Decades after its original mission, planners assumed its work would already be done. If this story of NASA's remarkable ongoing rescue of a nearly 50-year-old spacecraft fascinated you, like and subscribe, because as Voyager 1 continues drifting deeper into interstellar space, nobody, not even the engineers who know it best, can say for certain what it might surprise them with next, or how many more times this small team on Earth will manage to talk it back from the edge of silence.